Hey y'all. This section is about electric potential and electric potential energy. We're going to relate this to the idea of potential energy to what we learned back in first semester about gravitational potential energy. All right, so last semester we talked about potential energy as it relates to gravity, right? And we saw that if an object started high above the ground and there was a big distance between the object and the Earth, then it had a lot of gravitational potential energy and it could do a lot of work. Gravity could do a lot of work on it. And if you wanted to give something potential energy, an external force would do, like you, would do some work on it, lifting it upwards. But something that had a high potential energy could do a lot of work by gravity as it gets pulled down. Right. So if we relate this to charges, because with gravity, of course, two objects attract each other gravitationally. For charges, they're either going to attract or they're going to repel, depending on the situation. So in this first example, we're looking at two positive charges, right? And so if you move against its natural direction, you're going to have to do work. So for instance, if I want to move a positive charge here inwards closer to another positive charge, you're going to have to do some outside work. You're going to have to do work, give energy in order to do that. And if you do that work, it's much like lifting a rock up. You're increasing its potential energy. All right. And then once the positive charge is at B, if you release it and let it go from B to A, then gravity is going to do the work, meaning having it go back. And of course, the amount of kinetic energy when it reaches A is going to be equal to the work potential energy it took to get there in the first place. All right. So basically, if you're going against the natural, what it naturally does, you're going to increase the potential energy. So now, go back. Okay. So potential energy high is when like charges, that would be a positive and a positive, or a negative and a negative, are close to one another, right? Because the two positive charges or two negative charges will try to repel one another. So if you try to bring them closer, if this is a positive and this is a positive, we try to bring them closer, we have to do work on it and it will increase the potential energy. Same thing if they were negative. Okay? But if they were unlike charges, then they attract one another, much like gravitational force. So I have a positive force and a positive charge and a negative charge. And if I separate them, the more I separate them, the greater the potential energy is going to be. As they get closer, there's going to be less potential energy because they're going to be able to do less work. Right? So potential energy is low when like charges are far away and when unlike charges are close. That's the opposite of what we just said here. Right? Like charges are close together, unlike charges are far apart. It's high. When they're far away and close, the potential energy is low. Okay, so electric potential energy is just the potential energy due to its position relative to other charges, right? So again, a positive charge is going to have high potential energy when it's close to another positive charge. But if it's close to another negative charge, if it's close to a negative charge, it's going to have low potential energy. It has to do with their positions. Okay, it results from the interaction between the two charges. And of course, anytime that we move a charge, okay, because of an electric force, then work has to be done. Right, so draw these pictures in your notes if you're in Google Docs, you don't have to put circles, you can just put the pluses on them. All right, so in which case is the energy greater? Right, they're both positive charges, so they're like charges, so the energy is going to be greater in 2 because they're closer together. Right, now, which is the energy greater? Now they're opposite charges, so the greater is going to be greater when they're farther apart. More work can be done because these things are going to naturally move together. So the farther apart they are, the more you separate them, the more work they can do later. So the higher the potential energy that they have. All right, so there's a term called electric potential, which is very much related to potential energy. Right? It's the amount of work done or the amount of energy that it has per unit charge. Okay, and that's known as voltage. Okay, so something that has a lot of potential is also a lot of potential is also going to have a lot of potential energy. Okay, so you can compare that to the change in potential energy. Something that has a great potential is going to have a good change, a large change in potential energy. Right? The unit for this potential is known as the volt. Okay, and so we a lot of times call electric potential the voltage, and that's why you see that in the symbol it uses is of course V. Okay, and y'all have seen voltages when we talk about like batteries and things like that. And we'll talk more about voltage when we get into our next unit of electric circuits. Okay, so that's a short section. You not have to do any calculations involving. You don't have to do any calculations involving potential energy, but you just need to know the positions that they need to be in order to have high and low potential energies. All right. The next unit that we're going to look at, or next section we're going to look at, is Coulomb's law, which we'll do tomorrow. So, and that one's going to have the most calculations in it. All right. Y'all have a great day.